Hello friends, today we will discuss electrochemical machining. Electrochemical machining is a method of removing metal by electrochemical process. Normally it is used for mass production and for machining extremely hard materials. The materials that are difficult to machine using conventional machining methods where electrochemical machining is used. Its uses are limited up to electrically conductive materials only. Okay. In this video, we will discuss working principle of electrochemical machining, construction, working principle, working applications, and advantages and disadvantages. Now, whenever two electrodes, anode and cathode, this is the anode and this is the cathode, where anode is connected to the positive terminal and cathode is connected to the negative terminal, and both are immersed in a electrolyte such as NaCl. कुठला electrolyte आहे? NaCl. Anode, which is workpiece or tool, which is the cathode. Now, when voltage is applied across the two electrodes, material removal will start from the anode. बरोबर, ज्यावेळी voltage apply करणार आहे, material will starts removing from the anode म्हणजे workpiece, and the anode and cathode is placed very close to each other but without touching. Both anode and cathodes are bring together with very close to each other but without touching, and material removal will takes from the anode. Bro, in electrochemical machining, the material removal will takes place at atomic level, so it produces good surface finish. Now let us understand the chemical reactions that takes place in the process. As a potential difference is applied across the electrode, the movement of ion will start between the tool and the workpiece. Positive ions will move towards the tool and negative ions will move towards the workpiece. At cathode, the hydrogen ion takes place the electrons and gets converted into hydrogen gas. In the same way, iron atoms comes out from the anode, which in the workpiece as Fe++ ions. Within the electrolyte solution, ions combine with hydro ions and form sodium hydroxide. Ferrous ions combines with the chloride ions and then forms the ferrous chloride. Also, ion combine with the hydroxide, and finally removed material is formed in the form of sludge. बरोबर, आपण पुन्हा एकदा व्हिडिओ बघू. काय सांगितले? As a potential difference is applied across the electrode, the movement of iron will start between tool and the workpiece. Positive ion will move towards the tool, negative ion will move towards the workpiece. At cathode, hydrogen ions takes the electrons and gets converted into hydrogen gas. In the same way, iron atoms comes out of the anode, which is the workpiece, as F++ ions. Within the electrolyte, the sodium ions combines with the hydrogen ions and forms the sodium hydroxide. Okay, and ferrous ions combine with the chloride ions and then form ferrous chloride, and iron ions combine with the hydroxide, and finally removed material is formed in the form of sludge. बरोबर, आलं लक्षात? Now we will see various reactions that takes place in the machining processes. So these are the reactions takes place in the machining processes, first, second and third reactions. At cathode, the hydrogen ion takes the electrons and get converted into the hydrogen gas. Remember, this is the first reaction, you can see. Second, in the same way, the iron atom comes out of the anode, म्हणजे workpiece, as Fe++ ions, and okay, this reactions will takes place. Now within the electrolyte मध्ये काय होणार आहे, the sodium ion combine with the hydroxyl ions and form sodium hydroxide, and ferrous ion combines with the chloride ions and forms the ferrous chloride. And also iron ions combines with the hydroxyl ions and form iron hydroxide. बरोबर. आणि जे काही मटेरियल खाली राहणार आहे ते ॲज अ स्लज म्हणून राहणार, म्हणजे मटेरियल विल बी रिमूव्ड. Now we will see the construction of the electrochemical machining. This is the first power supply. Okay, direct current is provided. Electrolyte, NaCl electrolyte is used. Function of electrolyte is carries current between the tool and the workpiece, remove the products from the internal electrode gap, removes the heat produced due to passage of the current. Here this is the tool, tank for the storage of the electrolyte, workpiece, work holding or workpiece holding device, pressure gauge. त्याच्यानंतर आहे तो हा फ्लो मीटर, फ्लो कंट्रोल वॉल, for pressure relief valve. In case pressure is increased in the supply line, this pressure relief valve opens and bypass the electrolyte to the tank. For the pump help in circulating the electrolyte. For reservoir tank, नंतर फिल्टर म्हणजे रिमूव्ह करण्यासाठी, इलेक्ट्रोलाइट मधून डर्ट पार्टिकल्स रिमूव्ह करण्यासाठी. फॉर सेंट्रीफ्यूज हेल्प्स इन स्प्रेइंग द स्लज फ्रॉम द इलेक्ट्रोलाइट सेपरेटिंग, आणि sludge container where sludge is collected. Okay, this is the construction. Application of electrochemical machining. So the electrochemical machining process is used for die sinking operation, okay, profiling and contouring operations, for drilling operations, for grinding operations, okay, trepanning and micro machining. It is used for machining steam turbine blades with closed limits. Advantages. The advantages of electrochemical machining are negligible tool wear, complex and concave curvature parts can be produced easily by the use of convex and concave tools. No forces and residual stresses are produced because there is no direct contact between the tool and the workpiece. An excellent surface finish is produced, less heat is generated. So these are the advantages. Disadvantages. The risk of corrosion for the tool, workpiece and equipment increases in case of saline and acidic electrolyte. Electrochemical machining is capable of machining electrically conductive materials only. So this is the major disadvantages. High power consumption, high initial or investment cost. So this is the electrochemical machining. Thank you.